Hi. It's great to see you all. I'm Brian Amerige. Excuse me. I'm Brian Amerige. Among other things, I worked on Paper's gestural architecture, and I'm here to talk about some of the things that we learned along the way and how they might help you make your apps a little bit more interactive. So one of the design principles that we have while we're building Paper is that everything should be interactable all the time. And that means that you should never get caught waiting for an animation to finish or for gestures to stop conflicting when you really want to do something else. And just in case you haven't seen this in Paper, here's an example. No matter what you're doing with this photo, you can always open and close it. Even while it's still animating close, you can still pinch the strip down. It's always interactable. Some people think that this is a gimmick and that it's just sort of a fancy and nice extra bit of polish. We strongly believe this is not a gimmick. On a device that is defined by its gestural interface, this is really important. When I think about the first time that I used one of these, I remember how it felt like magic. And we as iOS engineers know that that's because Apple removed a layer of indirection. Suddenly, we were interacting directly with the content. When we block interaction, it's very frustrating for the people who use our apps. It opens a gap between what people want to do and what the phone is letting them do. And that's really sad. And to be honest, it kind of breaks my heart a little bit every time I see it. Because it breaks the promise of what a gesturally driven device is capable of. The truth is, this is actually really common throughout iOS. Here's the Photos app, for example. Notice how when I try to pinch closed, the first few pinches are missed. And then when it's closing and I try to open it again, it takes 3 taps to open this. Why? Well, if you study people who try to interact with things like this, you discover a kind of funny fact. Animations actually take longer to quiesce than they appear to take. And so it looks like the animation is finished, but it really hasn't. And so you swipe and you try to interact, and it's ignored. And the world is a more sad and frustrated place. So let's not do that. Let's make everything interactable all the time. So there's a tendency to think about animations as something that you sort of fire and forget. You know, as a fancy way from getting from point A to point B. And this comes from the days when that's really all animation could be. You know, days where building something like Paper just wasn't possible. Today, we like to think about animation as being about understanding. It helps you understand how interaction with an object will and should behave. And to build highly interactive interfaces like Paper, we need to internalize the fact that animations they're potentially always active. They're not an interim state. And so we can't do things like wait for them to finish or just forget about them after they're fired. So we have to think a little bit differently about animations to build these kinds of interfaces. This is a corollary to that. There are some non-starters when it comes to building these kinds of interfaces. Namely, while they're both incredibly convenient, both implicit animations and UI view animations are off the table if you want to build these kinds of interfaces. And that's because it's very inconvenient to cancel these. And even if you could, they almost always feel wrong when they follow gestural interaction. So we can't use these. So what about core animation? Now, technically, you can use core animation, because you're probably thinking you can cancel it by removing the animation from the layer. And that's true. But it gets cumbersome, because core animation operates on the render server. And what that means, as far as we're concerned, is that the current values of the animation are only ever committed to the presentation layer. And so if you were to just remove an animation from a layer, it would appear to jump back to the model layer, the values on the model layer. And so to prevent this sort of thing, to prevent that jump, you have to do something that looks like this. You have to pull the presentation value from the presentation layer, then you remove your animation, and then you immediately apply it to the model layer. So let me tell you, at scale, this is not fun. If you think about some of the animations we have in paper, some of the interactions we have, like when you pick up a photo, there are about 5 or 6 animations happening simultaneously when you do that. So this sort of thing gets very hairy. Now, on the other hand, Pop is a client-side animation framework. It animates the model layer. And so removing an animation is naturally seamless. If you were to remove the animation, the layer stays exactly where it was on the last frame of the animation. Pop also supports, as Keeman mentioned, the mutation of its to value on the fly. And so for discrete gestures, something like a tap, this makes interruptions really easy. So if you imagine, for example, that we're animating the size of a photo, when you tap it, open or close it. To do this, all you're doing is when you tap, determining the opening size to animate to, and then assigning that as the to value to your animation. And that's it. That works. But what about continuous gestures? Things like pinches, pans, rotation. It's a little trickier, but if you're using Pop, it's actually not that bad. So going back to the photo example, if the user starts pinching on a photo while it's opening, while it's animating opening, what you want to do is you want to kill the size animation. And then, like we mentioned, the photo is going to be stuck right where it was, under your fingers. And so then you can allow your gesture recognizers to dictate the movement of the photo. And then, when you do something like a throw gesture, you have a newly determined end state, and you just animate to it. So, a little more complicated, still not that bad. But there are some other complexities that you might run into when you're building these kinds of highly interactive, always interruptible interfaces. And so there are 2 other recommendations that we have. First, try to avoid using frame in your layout code. That sounds kind of funny, right? The trouble with frame is that it depends on transform. And when you use set frame, it resets the frame of the layer or the view or whatever, what have you, to the identity transform. And so if we're operating under the assumption that animations can be active at any time, even during layout, and you're animating the transform, like you would be if you were to animate something like scale or rotation of a layer, setting the frame during your layout will wipe out that transform, and it'll jump. So instead, what we recommend is using bounds and position, because these setters don't affect the transform. Apple recommends this approach as well. Second, this also sounds kind of funny. We don't use double tap gesture recognizers in paper. And that's because when you introduce both a single tap and a double tap gesture recognizer into the system, it needs a way to distinguish between single taps and double taps. And the way it does that is by introducing a delay into single tap gesture recognition. And so what you basically have is a system where you tap, there's a delay where it tries to say, is this going to become a double tap? And if not, it fires. But the end result is that this feels very slow and unresponsive. And because single taps are so much more common and generally more important because they're used for navigation, we just avoid double tap recognizers altogether. The next thing I want to talk about is about the gap between a gesture and an animation. Often that gap is very big and jarring, and it makes gestures feel fake, because you're no longer interacting directly with the content. We want to eliminate that gap. We want our gestures to transition seamlessly into animations. We want them to feel like one continuous motion. And to do that, we need to think about animations as physically decaying continuations of gestures. We think about this a lot, so I'm going to say it again. We think about animations as physically decaying continuations of gestures. And so if we think about this photos case, you can see that the gesture flows right into the animation. like it's one continuous motion. And you really can't tell where the gesture ends and the animation begins. How do we do that? Keeman touched on this. The answer is actually really simple, but it's really underused. UI Pan Gesture Recognizer has a method called velocity in view, and it returns the velocity of a gesture in points per second in the coordinate system of the view that you pass in. And so to bridge that gesture to animation gap, you take that value, the velocity from the gesture, and you pass it into your pop animation. It helps to visualize this, to understand the full system, though. This is a graph of velocity over time. The beginning of this graph is where you begin moving the photo underneath your finger. And then here, this is where you've completed the throw gesture. You've lifted your finger off of the screen. And then immediately after that, you can see that we kick off an animation seeded with exactly the same velocity. This is the gap being bridged. This is what makes it feel like one continuous motion. And then the rest of this velocity life cycle is pretty much what you might expect from a spring. Springs have a friction value that expresses how they decay over time. And so that's what you see happening here. The animation's velocity decays. And then assuming you don't interrupt the animation, which we support, you'll see the velocity quiesce towards 0. The last thing I want to talk about is really just some quick tips about how to manage simultaneous recognition of pinches, pans, and rotation all at once. So imagine for a moment that you just pinched this photo closed, and it's animating back to the story card. And now, then imagine you put your fingers down again. It should just stick to your fingers, right? Well, unless you're careful, it won't. In most implementations of this sort of thing, it'll jump back to having 0 rotation. And that's because most implementations would do this. They would apply the gesture recognizer's value directly to the view or the animation. We can't do that. Why? Well, the answer is that the values that you pull from gesture recognizers are relative values. They're relative to when the gestures begin. And so if you begin a new gesture that interrupts an animation, the gesture recognizer doesn't give back a value that reflects that initial presentation value. So in this case, the rotation recognizer's rotation doesn't reflect the initial rotation of the layer. And so to work around this, a common strategy that we use is to separate the base values from the relative values by stashing those base transform components when the gesture begins. And so you stash things like the rotation, the scale, maybe even the translation. And then, when the gesture updates, you combine these values. You combine the base values with the relative values that you pull from the recognizer. And this yields a value that you can apply directly, is impervious to interruptions to animations, and it works regardless of which gestures in the set of supported gestures are currently active. So to recap, there are 3 things that get you really far when you're building highly interactive interfaces. First, we want to make everything interactable all the time because it delivers on the promise of a gesturally driven device. Second, we want to bridge the gap from gestures to animations by seeding your animations with gestural velocity. We want to see one continuous motion. And lastly, we want to delight people who use your app by letting them do the things that they only playfully try, like pinching and panning and rotating all at once. If we all commit to doing these kinds of things in iOS, the iOS community, world, platform, ecosystem is going to be a less frustrating and more playful place. And now I want to welcome up Scott to talk about the asynchronous UI technology that allows an app like Paper to be so gesturally driven without sacrificing performance. Thanks.